This is section 1.3 on data collection and sampling techniques. Now, we already went over a lot of sampling techniques in the last section, 1.2. We'll do a quick review of those here. The book has some kind of interesting section labels in this chapter. So the main sampling techniques were really in 1.2 rather than 1.3, but we'll do what we can with this. All right. One thing that is discussed in 1.3 that we haven't seen before is the idea of anecdotal evidence. And this is something that really most of us have seen. It's data that's collected in some sort of haphazard fashion, like just whatever you can get, whatever story you've heard, becomes part of this quote, quote, data. This is just anecdotal evidence. So an anecdote is like a little story. So it's just haphazardly collected, and the data here are really not a huge data set. The data only represent one or two special cases. Okay, so it's not a fully fleshed out survey or study or anything. And so for that reason, it's really unclear whether these few small pieces of data are actually going to be representative of what's really going on. So it's unclear whether the data actually represent the population. Okay, and the text has a few good examples, but I'll give you my example that I thought of, and then see if you can think of your own example of some anecdotal evidence. So remember, this is some sort of story or one or two special cases that you've heard of, and we're trying to come up with a conclusion based on that. This is not a good thing to do, by the way. Not good. This is not scientific. Okay, so here's my example of anecdotal evidence. So 3 packages got stolen off my doorstep at my old apartment. That is true. None have gotten stolen yet where I live now, so my new neighborhood must be safer. Um, so this may be the case. Maybe my new neighborhood is actually safer, but this is not enough evidence to come to that conclusion. Um, sure, I had some packages stolen at my old place, and nothing's gotten stolen yet in my new place. But there are a variety of factors at play here. Like I haven't lived as long at the new place. I have a safer or more hidden receptacle for packages. The housing isn't quite as dense. So yeah, there are a lot of different factors. This is not a valid conclusion based on this anecdotal evidence. Anecdotal evidence is not enough. Okay, so see if you can think of your own example of anecdotal evidence, like some story or some special case you know of that may have led to a conclusion that wasn't entirely true. All right, so this is not good, not a scientific process. Let's review quickly our different sampling techniques, random sampling techniques that we've learned about, because these are good and scientific ways of getting data. So yes, these are good, or specifically, the random sampling techniques are good. And why is it generally best? See if you know. All right, you can review in section 1.2, but the overall idea of why random sampling is good is because it tends to reduce bias. All right, getting a nice random sample from the population increases the chance that the sample will be representative of the overall population because we're just picking at random. Okay, let's review our 4 random sampling techniques that we've seen. All right, first one, we'll start with the simplest, which is simple random sampling. Okay, and that was just where you would generate randomly numbers that would select random individuals from the overall population. Simple random sampling. And then we have systematic sampling. Okay, and that's where you randomly choose your starting point and then choose every nth or every kth individual after that. So maybe you start on individual number 5 and you take every 6th person from that point on. That's like a systematic sample. We also had stratified sampling, stratified, and cluster samples. And those were starting out in kind of the same way. With a stratified sample, you break your population down into groups called strata, and then you pick some individuals from every stratum. So a proportionate number of individuals you would select from each of those groups. And then a cluster sample, you again divide your population into groups. They're called clusters in this one. And then you would randomly pick several different clusters, and everybody from that group would become part of the sample. So the difference between those last two, remember, stratified is when you pick some individuals from all of the groups. So a few individuals from each stratum. And then cluster sampling was where you took all the individuals from some of the groups. Okay, you pick a few clusters and you take all of the individuals in that cluster. Okay, so those were our 4 good random sampling techniques. And then we also looked at 2 techniques that could easily lead to non-random sampling. And these tend to have bias in them, so these are not great techniques. All right, so again, not good. Okay, the first one of those was convenience sampling. And that was where you just got data wherever it was most convenient. So whoever's physically nearest to you or whoever is easiest to ask, all right, or whatever object you can reach gives you your data point. Yeah, that's convenience sampling. While easy, it's not often not representative of the population. And then the other one was volunteer sampling, or having a self-selected sample group. People choose themselves. Okay, self-selected sample. And remember, the classic example of this type is like a review website. So people choose, they select themselves, they volunteer to be part of the group that leave reviews. Okay, you're not forcing people to participate. So they select themselves, and this often leads to strong opinions coming out. So that can be a biased type of sampling as well. All right, in the next video, we'll look at some examples, looking at some different studies and seeing what we can conclude about some sampling techniques.